All right, good evening, fellow evolution students. Welcome to the first screencast of the semester. My name is Matthew Sowards. I'm running solo this week. And because I'm running solo, I have a little bit more of a formal presentation than I normally would have. Hopefully, it's more interesting than just staring at my face this whole time. Anyway, so for preparation questions, lesson 2, part 1, I had question number 6. And I created this PowerPoint just so you don't have to stare at my face the whole time. And question 6 was, describe the 3 examples of molecular homology presented in the text. And there they are. The first example was CMT1A, which is just a section of genetic code that is shared between humans, chimpanzees, and gorillas. The issue with the code is when there's unequal crossing over, it can lead to Charcot-Marie-Tooth syndrome type 1A. And Charcot-Marie-Tooth syndrome affects both, from what I understand, motor and sensory nerves. It causes weakness in when you would perform motor skills, so breathing, speaking, and then of course it also can cause slight deformations in especially the feet. So there's a picture of a foot that's a little maldeformed. The second example is processed pseudogenes. And what these genes are is they're genes that are created when reverse transcriptase accidentally reverse transcribes mRNAs to DNA. It's what reverse transcriptase is supposed to do, just not with what it does. And those genes just hang out in the genetic code. They're nice because they can both be aged through calculating how many mutations they've accumulated, and they can also be traced back through parent species. So species will pass them down because they just sit in that genetic code and are, of course, copied and passed on to their offspring. And then finally, the third example is universal homologies. These are just homologies, or basically genetic characteristics that all life forms share. And the big one is the genetic code. Every single living life form is made up of DNA and that code, and it's just a matter of what pairs go where and the combinations. So those are pretty much the answer to my question. I hope you enjoyed this presentation this week, and I will see you all in part 2.